All right, so lesson 1.5, distance, midpoint, and Pythagorean theorem. We've talked a little bit about distance and midpoint on the or on a number line already, and we are going to talk about it some more with um, the coordinate plane today. So we're going to go into a little more detail and learn a couple new things. All right, so first of all, a midpoint, I think we've kind of already talked about this, but a midpoint is a point that separates a segment into two congruent segments, or it bisects the segment. I think we've talked about this before, but this word bisects means splitting it into two congruent segments. So a midpoint is that halfway. On a number line, which is mostly all we've looked at so far, you can find the midpoint by using this formula here, endpoint plus endpoint divided by 2, right? So if my endpoints are A and B, I'm just going to take A plus B divided by 2. So let's give it a try. Okay, this problem is going to ask me to find both the distance and the midpoint. So we've already talked about distance, but we'll review. So I'm looking at R and S, okay, RS. So remember, distance is the furthest right value, or the greatest number, minus the left number, or the smaller number. So if I do it that way, I'm going to take -3 minus -10. And when I subtract a negative, I'm really adding. So -3 plus 10 is 7. Okay, so my distance of RS is 7. Now the midpoint, I'm just going to take A plus B divided by 2. Remember, A and B just are the endpoints. So -10 plus -3 divided by 2. -10 plus -3 is -13. Divided by 2 would be -6.5. Okay, so this number is a distance. That's 7. This 6.5, the midpoint, is actually a value on the number line. So I could put a little dot right here and say M for midpoint would be at -6.5. Now, if I want to find the midpoint on a coordinate plane, so not on a number line, but on an XY coordinate plane, right? Where we have X, which goes horizontally, and Y, which goes vertically. We would have we could have a point where it would be x1, y1, and we could have another point that would be x2, y2. And if I want to find the midpoint of that, I'm going to use this formula here. So I'm going to add the x values together, divide by 2, add the y values together, divide by 2. So let's try that one out. Okay, so again, here's my points. I have E is 7, 5, and F is 2, -4, and I want to find the midpoint. So I'm going to take x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. So E, this is going to be my x1 and y1. This is going to be my x2 and y2. So I'm going to take and plug in 7 plus 2 divided by 2. And then I'm going to do 5 plus -4 divided by 2. So 7 plus 2 is 9, divided by 2 is 4.5. And then 5 plus -4 would be like I'm subtracting. So 5 minus 4, which is 1, divided by 2. So you can say 1/2, or if you want to put that as 0.5. So this would be my midpoint. And if I look at it actually on the graph, here's 2, 4.5, and then right about here, 1/2 would be my midpoint. And you should be able to tell, right, that then this distance is going to be the same as this distance, okay, because that midpoint is exactly halfway between. Now, what if I'm given the midpoint? So G is the midpoint, and I'm given one endpoint. So this is one endpoint. Okay, I want to find the other coordinate. So I have E, which is at 18, negative 21. I have G, which is the midpoint, which is at 8, negative 9. And then I have F somewhere, right, that we don't know. So I have endpoint, midpoint, and endpoint. This is how we're going to set up these problems. And because this midpoint has to be exactly halfway, whatever I do from here to here, I have to repeat that process from here to here. So from 18 to 8, I'm subtracting 10. I'm going down by 10. So I'm going to do that same thing here. So 8 minus 10 is negative 2. So that's my x value. Do the same thing here. From negative 21 to negative 9, I'm increasing by 12 here. So I'm going to do that same thing. Plus 12, negative 9 plus 12 is 3. Okay, so my coordinates for F, remember when it says coordinate, I need an X and a Y, would be negative 2, 3. Okay, and we just do that by setting up endpoint, midpoint, endpoint. All right, Pythagorean theorem, next thing we have to talk about. Hopefully you've seen this before, but when we have a right triangle, so we have to have that right angle there, we can use, if we know two of the sides, we can find the third. So A is what we call a leg, B is also a leg, and C is the hypotenuse. The only one that really matters, that has to be the same every time, is this hypotenuse, C, and it has to be opposite the right angle. Okay, it's the longest side. When we use this, A and B can be interchangeable because they're both legs. So we don't really need to differentiate what's A, what's B, but C is really important. We have to have that. Okay, so if we know try and use this and solve for it. So I'm going to label, I have A, I have B, and then again, opposite my hypotenuse, opposite my right angle is C. So if I'm going to use A squared plus B squared equals C squared, I need to plug these in. So 7 squared plus 8 squared equals x squared. All right, so 7 squared is 49 plus 8 squared is 64. So that is 113 equals x squared. Now, to figure out what x equals, because it's a square, we need to take the square root. So this is just a button on your calculator you're going to have to use. And so this x value should be, let's round to the nearest tenth, so 1 decimal would be 10.6. Okay, so that's if we're finding C. We just plug stuff in and solve for x. Now, in this one, second example, if I label, again, let's start with C because that's the most important. We find our hypotenuse opposite our right angle, the longest side. A and B doesn't really matter. I can make either one A, either one B. C is the one that matters. But now when I go to plug in my formula, I'm using the same formula, but where I have things is a little different. So 3 squared plus x squared equals c squared. So now I need to solve this a little bit differently because I have x on the side with my 3. So 3 squared is 9 plus x squared equals 11 squared, which is 121. Okay, now I'm going to subtract the 9. So I get x squared equals 112. And then I'm going to take the square root of 112, because again, I have x squared. To undo that, I need to take the square root. So x equals 10.6. Okay, so this is 10.6. All right, so same formula, this a squared plus b squared equals c squared, just a little bit different way of solving depending on what I know and what I'm looking for. All right, so next we have distance on a coordinate plane. So we've talked about distance on a number line. This is a little different, okay? Remember our coordinate plane is our x and our y axis. So x left and right, y up and down. So we have both variables to think about when we're finding the distance, okay? This is our distance formula. It actually comes from the Pythagorean theorem. You can kind of see we have a value squared plus a value squared, and we're taking the square root of it. But it's a little bit easier because all we have to worry about is just plugging straight into that formula. Okay, so what's the distance between u, which is at -7, 5. Oops, wrong one. So here's x1, here's y1, and then v, x2, y2. So all I'm going to do is just plug in to this formula here. So x2 is 4 minus x1, which is -7. And then I'm going to square that. And then y2, -3 minus y1, which is 5. And then I'm going to square that, and I'm going to take the square root of all of that. Okay, so 4 minus -7. Again, when I'm subtracting a negative, it becomes a positive. So that's 11 squared. -3 minus 5 would be -8 squared. And so 11 squared plus -8 squared is 185. So in order to find the distance, I need to take the square root of 185. And again, let's round to the nearest tenth. So 1 decimal point, I get 13.6. So the distance between those two would be 13.6 units. All right, so that's it for my examples. If you guys want to work through the rest, on here you can. The following slides are some extra examples that we will go through in class together. But if you want to give them a try on your own first, go for it. And I will see you soon.